So, dear students, we'll see the first startup of the high voltage engineering. So, if the transmission voltage is doubled, as you know, the power transfer capability or the capacity of the system becomes 4 times, and the line losses are also relatively reduced. As a result, stronger and economical system. So this is a very important line which gives the total details that if the transmission voltage is doubled, the power transfer capability of the system becomes 4 times, and the line losses are also relatively reduced. As a result, stronger and economical system. So high voltages are used for a wide variety of applications for transmission of large bulk of power over long distances. So we'll be just relating this with a simple formula. The power transfer capability is approximately P equals to V square by Z suffix L. That is, the electric power P transmitted on an overhead AC line increases approximately the square of the system operating voltage. So this is what we require for the basics as we are entering into the subject. So the diverse conditions under which a high voltage apparatus is used necessitates careful design of its insulation. I have just underlined that one. So it is that we are going to design the insulation for the high voltage apparatuses and the electrostatic field profiles. Selection of an insulation is in relation to the direct strength, corona discharges, and other relevant factors. So voltage stress, we'll just have a simple view. The voltage stresses on power system arise from various over voltages. You're known to this. These may be external or internal origin. External over voltages are associated with lightning discharges, and internal over voltages are generated by changes in the operating conditions of the system. So designing of the voltage stresses, because these, so we'll first read it out. That is, the first one is determination of the voltage stress which the insulation must withstand. If you are going to produce some product, you will see the withstanding capability of the product. So here the insulation, you want to see at what voltage the insulation is going to break or starts conducting. So you want to know its withstanding capability. So it may be with respect to the voltage or with respect to the current. So the point number 2 is determination of the response of the insulation when subjected to these voltage stresses. So you want to observe what kind of changes these insulations make with respect to different voltage stresses. Based upon this, you are going to design for your usage. So testing voltages, testing with primary frequency voltages, there are different types of tests that are being used. So you will be just focusing on the few of them which are more important for the student at this particular level. The test voltage is set at a level higher than the expected working voltage in order to stimulate the stresses likely to be encountered over the years of service. So whatever products you are going to design, so you want to know the lifespan, the age, the aging, as the age goes on, how it behaves, what are the changes. So those things you will be calculating, or the pre-calculations are to be done, but these are done with respect to testing with power frequency voltages. Again, one more is testing with lightning impulse voltages. Lightning storms with induced will induce steep rising voltages in the line. The magnitude of these over voltages may reach several thousands kilovolts. Depending upon the insulation, impulse voltages are extensively used in research laboratories for the studies of electrical discharge mechanisms when the time of breakdown is of the interest. Breakdown, as I have told you, is that property of an insulation where it loses its withstanding ability or capability and starts conduction. So this is what some of the few points that I wanted to discuss today. So thank you.